Okay, let's get started. So we're going to be doing Chapter 6 in physics, general chemistry, biology, and organic chemistry. We'll continue in that order as usual. I forgot to mention last week when we did organic chemistry, the reason we did not do organic chemistry was because Chapter 5 was aromatic chemistry. Which is in the gold standard, just to give you background information and to have a complete review of organic chemistry. But the new MCAT CBT has no specific aromatic chemistry on the exam. So that goes for alkene chemistry as well. No specific alkene chemistry on the exam. So that's the story, and this week, however, it will be alcohols and substitutions, so we'll definitely be doing some organic chemistry. But we're starting in the same order as usual. We'll start with physics, and physics is, for the MCAT Chapter 6, is fluids and solids. The truth is that with regards to the MCAT, it's mostly fluids. There's very few questions, very rare that they actually have questions on solids, and when they do, they actually supply the equations for you. But for fluids, these equations are equations you simply have to memorize. And the most important first equation of these equations that you absolutely positively must memorize is the equation for specific gravity. And for specific gravity, the equation is simply that the specific gravity is equal to the density of a substance divided by the density of water. So the density of whatever substance you're talking about divided by the density of water. Now, of course, you have to know what the density of water is, and I'm sure you're thinking, density of water, 1. Right. So we have to look at the units. So the units of the density of water, it's 1, you can say gram per centimeter cubed. It's also 1 cubic centimeter, 1 gram per cubic centimeter, you can say. Or you can say 1 gram per milliliter. That's all the same thing. So that's the density of water. But the MCAT also, for whatever reason, likes to occasionally use the units kilograms per meter cubed. Now you can calculate what this is, or you can memorize it. Either way, these are units that you need to know. And if you want to memorize it, it's 1,000 kilograms per meter cubed. If you get into the exam and they use some unit that you're not familiar with, you can always calculate it going back with this, with the fact that it is 1 gram per cubic centimeter. You use that, you use dimensional analysis, meaning you pay attention to your units, and you will be able to convert from 1 gram per cubic centimeter to whatever other units that they give you. But these are the least amount of information that you must memorize. So when you're talking about liquids or fluids, and a fluid, of course, is anything that flows. So fluids includes liquids, but it could be gas, because you can have air flowing over, for example, a car, or flowing over an airplane's wing. Well, the air would be considered to be a fluid, because a fluid is just going to be anything that flows. But when you're talking about fluids, whether it be liquids or gases, the concept of pressure becomes very important. Now, you may remember from just the most basic equation with regards to pressure is that pressure is force per unit area. And you can think about that. If you're applying pressure, say, to a table or to a chair, you are applying pressure to the table or chair. You are applying a certain force over a particular unit area. So force per unit area is the definition of pressure. Now let's imagine that we're looking at a fluid. Say this is a container, and it contains some fluid, and we're going to change depth of the fluid, going from one level to another level, and this change in level will be a change, delta H, as we go from one level in the fluid to another. Now, when we discuss what the pressure changes would be when you go from one level of the fluid to another, we can discuss that change in pressure as depending on, well, obviously it will depend on the change in height, because just think about it. If you're in some fluid like water and you go from one level to way, 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 way deep down into the water to some deep level down here, then as you're going from a higher level to a lower level, clearly there's more and more water above you. That water or fluid is going to exert more pressure on your body, more force per unit area, as there's more of this dense material above you. So, and that's going to depend on how low you go. So that's going to depend on delta H. Other things that it should depend on, logically, it'll depend on the density of the fluid. Clearly, if the fluid is water, it would have a certain pressure on your body. But if the fluid is mercury, which you know is metal, clearly that's going to be more dense than water, and it's going to exert more pressure. And so the fact that it is more dense means that the pressure that you would experience would also depend on the density. And finally, if you were to experience this on the moon compared to if you experience it on Earth, there would be also a difference in pressure, and so gravity becomes an important element. So here's another equation you must memorize, and this is that the change in pressure is equal to rho g delta H in a fluid. Oh yes, just a little thing that I have to mention about area, because of course this is per unit area, but just in case you forgot some high school math, if that area, because sometimes they'll be talking about unit area, and the area that they're talking about is cross-sectional area of a cylinder. So if you imagine a cylinder and you talk about the cross-section of a cylinder, then we're talking about a circle. So, and the unit area for a circle, you may remember, is pi r squared. So it's pi r squared, and pi, which you of course must know, is 3.14. And if you can believe this, there was once a town that tried to legislate pi as 3.0 because they thought it was too complicated, this 3.14159 stuff for students. Anyway, fortunately that did not make it all the way to the Supreme Court. So that's pi r squared, that's the area of a circle. 2 pi r, of course, is the circumference of a circle. And yes, that's basic information that you are expected to know for the MCAT. So that's a situation of a fluid that's just standing there. Well, what happens if we have a fluid in motion? For example, you have a system of pipes, and and there's fluid that's moving through this system of pipes. As I mentioned before, if you took the cross-sectional area of these pipes, it would be a circle because they're pipes. There are different sizes, but they're pipes. And if you're looking at fluid that's moving through a system, then we have to use a different equation, which is the equation called the continuity equation, because the fluid is moving through in continuity. And this equation suggests that rho VA is a constant. So this is another equation you must memorize. Rho VA is constant. Rho, of course, is the density. V is the velocity, and A is the cross-sectional area. So, so this is a constant throughout the system. Okay, so what that means is that let's say that we have A here, B here, and C here. And this is a system of pipes where the fluid is flowing through the system. What it's telling us is wherever you have the greatest cross-sectional area, you have the lowest velocity, because this must be constant. We assume the density will be constant throughout as long as this is incompressible, meaning that you cannot compress the fluid into smaller areas, meaning more dense, or blow it up into larger areas. So they would just use the word incompressible during the exam. Don't worry, they're not going to have a fluid that's compressible and then you also have to calculate the velocity or the cross-sectional area. They won't do that on the MCAT. So the fluid is flowing through A, B, and C through the system of pipes, and the cross-sectional area is clearly changing. At A, the cross-sectional area is greatest. At B, it's smallest. So that means at B, because of its smaller cross-sectional area, the velocity is highest. So the velocity is highest where you have the greater cross-sectional area. This equation is, okay, so that's the equation of continuity. There's one more equation that is relevant to fluids in motion, and that is Bernoulli's equation. Bernoulli's equation you do not need to memorize because usually they'll give it to you, but you need to have an understanding of the equation. So Bernoulli's equation is P the pressure plus 1/2 rho V squared plus rho GH is a constant. Now you might look at this and say, whoa, that's a big equation, but it's actually quite a simple equation once you look at it, because to begin with, we're talking about a fluid in motion. So fluid in motion is going to have some kinetic energy, and notice that the equation 1/2 rho V squared, how it's similar to the kinetic energy equation that we've seen before, and that is 1/2 mv squared. But we're talking about a fluid, so volume is important. So this is 1/2 mv squared divided by volume. In other words, 1/2 rho V squared. We also, when talking about conservation of energy, we talked about the potential energy equation, mgh. Well, here is mgh divided by volume once again. So it's rho gh. And when talking about fluids, pressure is always a very important term. So we have pressure plus 1/2 rho V squared plus rho GH is a constant. And usually what they'll do is they'll give you the equation and then they'll have questions seeing if you understand how you can manipulate this equation. For example, if you have a fluid, because this equation is constant, so if you have a situation in which pressure is more or less constant, but you have you increase the height in comparison to another situation, so you increase the height of the fluid, well then you're expecting a decrease in velocity as long as the density is constant. And as I said before, for the MCAT, normally they're going to keep the density constant. So an increase in velocity would be more paired with a decrease in height, etc. And all this will be depending on what other information that they'll be supplying in the problem. But these are some of the basic equations that you need to know. Okay, so let's look at a little problem here. So this is a problem that they could easily ask on the MCAT, and the question is, consider the following cylindrical hydraulic system shown in its middle cross section. All of the pistons are in the same plane. Pistons A and B have the same size. Which is smaller than piston C? To obtain maximum amount of force on piston C, one should exert a given force of 8 newtons on piston A only, A and B, B only, piston C. Okay, so you have 25 seconds to answer this question, and go ahead. Okay. So yes, that's it. The answer is B, and it's based on the idea that um, that the pressure is force per unit area, and that's that cross-sectional area. It represents the cross-sectional area of the piston here and the piston here, and that cross-sectional area is the same of A and B, and F is the force, and it's the same for both of them, which is 8 newtons. So if the force and then if the force and the cross-sectional area are the same, then the pressure is going to generated will be the same either from A or B. Of course, the assumption is that this is well, it doesn't even matter if it's incompressible or not in terms of the fluid, but normally, of course, it would be an incompressible fluid, and so the effect is the same. So yes, so the answer is B. Now, another concept that's important for fluids is that of Archimedes' principle. So Archimedes' principle tells us that it talks about a buoyancy force, and it tells us the buoyancy force on a body which is immersed in a fluid equals the weight and volume of the fluid which is displaced. So the buoyancy force on a body which is immersed in a fluid equals the weight and volume of the fluid which is displaced. And the bottom line with Archimedes' principle is that the the downward force, which is of course the weight, the downward force is equal to the buoyancy force. Wow, I don't know what letter that was. Is equal to the buoyancy force. So let's, as an example, let's imagine a glass of water with an ice cube in it. And the ice cube's just floating in the water, and if you try this experiment at home, you'll notice that the ice cube has just a little part of it which is above the surface of the water. So my question to you is the following. When that ice cube melts, will the surface of the water go up a bit, go down a bit, or remain the same? So when the ice cube melts, will the surface of the water go up a bit, go down a bit, or remain the same? Yeah, it actually will stay the same. The idea here is that the reason why the water level is where it is, the reason why it is at that level, it's because the ice cube itself is pushing down with a certain force. So the ice cube is pushing aside water with a certain force. The force that it is able to push aside is equal to the weight of the ice cube. When the ice cube changes shape, it doesn't matter what shape it becomes. It cannot push any more or any less because the weight of the ice cube has not changed. For example, if you took some styrofoam and you put the styrofoam in a bucket of water, the styrofoam is going to have a little bit of the styrofoam is going to be under the surface of the water, just a little bit. Of course, most of the styrofoam will be above the water, but a little bit will be under the surface of the water. How much? Well, the styrofoam can only push aside a certain amount of water. That amount of water must be equal to the weight of the styrofoam, because that's the only force the styrofoam has. It pushes down with its weight. So it pushes down a certain amount of water equal to the weight of the styrofoam. Now, if I took the styrofoam out of the bucket and I squished it and I squanched it and squished it and squished it and threw it back in the bucket, would you expect that the styrofoam would push aside any more or any less water? It would be the same, because the weight of the styrofoam hasn't changed, so its ability to push aside water has not changed. The weight doesn't change, then the buoyancy force doesn't change. Now, with respect to the MCAT, there is one other thing that you absolutely need to know, and that is the concept of how specific gravity relates to Archimedes' principle. And this is the importance of specific gravity. If you have a specific gravity equal to 1, meaning the density of your substance has the same density as water, well then 100% of your substance will be underneath the surface of the water, clearly, because an example of a substance with a specific gravity of 1 is water. So water has the same density as water, so obviously water tends to be below the surface of water when you add it to water. So if you have something with a specific gravity of less than 1, so let's say a specific gravity of 0.8, so it's lighter than water, then the percentage of that substance that is expected to be below the surface of the water is 80%, and so on. Specific gravity equal to 0.1, for example, then we'll get 10% below the surface, etc. That's very important for the MCAT. I don't know why, but they love to bring up the concept of specific gravity whenever they talk about fluids, and they love to play on this idea that you can know the percentage of the substance below the surface of the water based on the specific gravity. So those are two concepts that come up often. Besides that, in Chapter 6, it also discusses fluid viscosity, which is not really often brought up on the MCAT unless they, unless they give you an equation that you can easily calculate things from. And but viscosity in general is just the resistance of movement of fluids. For example, it's sort of like, you know how you talk about friction among solids? You know, it's the same thing. For fluids have friction, and that friction is called viscosity. Chapter 6 also discusses surface tension, and again, there's equations with regards to this that you do not need to memorize. And for surface tension, again, if they have any equations, they will present the equation, and then you just need to basically plug in from there. And finally, there are a lot of equations that talk about solids in terms of shear modulus and the Young modulus and so on. None of those equations do you need to memorize for the MCAT. You should look at them, but you do not need to memorize them for the test. The equations that we do in this class, in the virtual classroom, and the equations that you see in the videos, all of those you need to memorize for the MCAT. Otherwise, you do not need to memorize them. Okay, so do we have any questions about physics before we move on to general chemistry? Okay. So, general chemistry, everyone's favorite, acids and bases. Okay, so there's a couple of things that you just have to be very clear to you with regards to acids and bases. You'll keep hearing the Bronsted-Lowry definition. Definition of an acid or a base. And basically, it's just the idea that an acid is a proton donor. And that has to be at the tip of your tongue, that an acid is a proton donor. There are things called Lewis acids and bases. Lewis acids and bases, it's defined differently, and it's defined as an electron donor or acceptor. That's Lewis. But Bronsted-Lowry, this is the one that they tend to bring up most frequently on the MCAT, and it is a proton donor. Rarely they'll mention Arrhenius, which was, he really actually gave the prelude to the Bronsted-Lowry definition. His definition was not exactly a proton donor, but it was close, and it more referred to H3O+, which our shorthand of that is simply a proton, because a proton in water really is going to make H3O+, because water has an electronegative oxygen atom, and H plus is, well, it's a proton, it's positively charged, opposites attract, so you get H3O+. But the Bronsted-Lowry definition as a proton donor is the most common that you're going to see. And of course, you have to have a certain comfort with certain acids that are powerful donors. These are acids that, people on, the common man knows are strong acids. So definitely you should know that. You should know what a strong acid is and a weak acid. If the guy who delivers your newspaper knows, then obviously you should know for the MCAT. And the guy who delivers your newspaper probably knows that sulfuric acid is a strong acid. So you should know H2SO4 is a strong acid. You should know hydrochloric acid, which is, probably on every second episode of CSI Miami, is a strong acid. So those are common strong acids, and many of the hydrogen halides are strong acids, including hydrochloric, hydrobromic, hydroiodic acid. Those would be all strong acids. There's also perchloric acid, which is a strong acid, and related to perchloric acid is chloric acid, which is as follows. All of these are strong proton donors. Organic acids are all weak. I know you've heard of acetic acid many times, but it's probably a pretty weak acid, since you probably have occasionally put it on your French fries as vinegar. So you don't tend to put hydrochloric acid or sulfuric acid on your French fries. So organic acids are all weak acids, but these ones here, these are strong acids that you really need to feel comfortable about. So the question was, in the gold standard, is it marked which equations must be memorized? No, because in the book, what's presented in the book is all the information that the AAMC tells you need to know. So the AAMC says X, Y, Z, then it's all in the book. In the videos and in the classroom is the nuance. It's like going to any course. When you have a course in college or university, you know that everything is in the textbook, but you go to class to determine what's going to be on the exam. What are the common questions that will be on the exam? Can you still get a question from left field that's straight from the book? That's possible. It's unlikely, but it's possible. But like most courses, most of the content is coming from the lectures and the videos. So now, of course, there's something called the pH scale. and to calculate the pH, which of course you have to memorize this and be very comfortable doing calculations with logarithms. pH is the negative log of hydrogen ion concentration. Now it's easy to calculate. Now of course, if you put P in front of anything, it's negative log of that. So POH, well, it's just negative log hydroxide ion concentration. pKw is going to be negative log Kw. And whenever you see a K, it's in general chemistry, these tend to be equilibrium constants, which means the product of the product over the product of the over the product of the reactants. Those are equilibrium constants. So pH is negative log hydrogen ion concentration. pH and POH are related because pH plus POH is equal to 14. And if you take the if you have a hydrogen ion concentration times the hydroxide ion concentration, we get 10 to the minus 14. So these are, and 10 to the minus 14, this is equal to the KW, the W being for water. So this is the water equilibrium constant. So let's say that well, actually we'll work out a problem like that together in just a moment. We'll do a bunch of problems with regards to hydrogen ion concentration and pH. Before we do those problems, something about titration. So here is a curve that you have to memorize because, you know, this is all part of your pattern recognition, which means to look at something and immediately recognize its meaning and its importance. This is a classic titration curve. Well, I didn't draw it that well, but it gives you the general idea. And here we have pH, and here we'll put volume of NaOH added. Okay, and this will be a titration curve for HCl. So here we have HCl, hydrochloric acid, strong acid, plus NaOH, sodium hydroxide, strong base, and, well, what would that give us? We've got hydrogen ion being liberated, and we have OH minus, so opposites attract, so that's going to make water, and then we're left with NaCl. So we have NaCl left over, and we have water being produced. So it's NaCl plus water. So this creates an expression that students tend to memorize in first year general chemistry, and that is when you add an acid plus a base, you get a salt, NaCl, that's regular table salt, sodium chloride, plus a neutral compound. Some people remember acid plus base gives me salt plus water, but really it's salt plus a neutral compound because it could produce an alcohol or other substances. So acid plus base produces salt plus neutral compound. Okay, so now let's look at this titration curve. What do we have? Easy to know, easy to memorize this shape. Of course, you should not, get this wrong on the following basis. First of all, a very, very high hydrogen ion concentration. High hydrogen ion concentration. So look back at this pH equation. pH is equal to negative log hydrogen ion concentration. So a high hydrogen ion concentration means a low pH because it's a negative log hydrogen ion concentration. Higher hydrogen ion concentration means lower the pH. So if we have a pH, say down here at 0, okay, which means we have almost no NaOH added, it's almost all HCl, so clearly the pH is going to be super low. As we add base, we're adding sodium hydroxide, we're going to have less and less hydrogen ion concentration and more NaOH. So when you have lots of base, the pH is going to be very high. So that's why the curve starts low, ends up high. Now in the middle is, is going to be the middle point of the titration where you're adding sodium hydroxide. This is when you have NaCl and water. Now if you have NaCl and water, water has a pH of 7 because it's neutral. 7 is the neutral pH, midway between, well, it's halfway up to 14. So water has a neutral pH, pH 7, so that will be the midpoint of the titration. Now this midpoint of the titration is what is called the equivalence point. So this point of the titration is called the equivalence point. And the equivalence point, so let's call that the equivalence point. And the equivalence point of the titration means that we have the same number of equivalents of acid and base. Same number of equivalents of acid and base. Equivalence of acid or base means that we have the same number of hydrogen ions as we have hydroxide ions. Now why don't we just say that? Why don't you just say H plus equals OH? Well, it has to be said this way, just in case you have, meaning the equivalence point has to be defined as the number of equivalents of acid equals the number of equivalents of base, because sometimes you might have a substance that's able to give more than just one proton or more than just one base component. For example, H2SO4. That's a diprotic acid. Diprotic, 2 protons. So it potentially can give 2 protons. So it has 2 equivalents of acid per molecule. HCl has 1 equivalent of acid per molecule. NaOH has 1 equivalent of base per molecule. CaOH2, calcium hydroxide, CaOH2, has 2 equivalents of base per molecule. So that's why the equivalence point is defined this way. Now notice that the equivalence point is what is called in math at the point of inflection of the curve, meaning it's the point at which the curve is literally changing directions. You can see how the curve curves one way down here, and then at a certain point its curve changes to another direction. So the point at which the curve changes direction is the point of inflection, which is the equivalence point, and we can see the pH, which is the equivalence point of this titration between HCl and NaOH. Okay, so that's that. Let's do some problems. Okay, so here's first problem here in general chemistry. H2SO4, sulfuric acid, is a polyprotic acid. Consider the following solutions of sulfuric acid and or its sodium salts. Just as a reminder, these problems are in the lesson section of the website, in the review part of the lesson section, just in case you're wondering. So we have solution 1, 0.1 molar H2SO4, solution 2, 0.1 molar NaHSO4, solution 3, sodium sulfate, and solution 4, a mixture of equal volumes of 1 and 3. Which solution has the highest pH? You have 20 seconds. Go ahead. So yes, the key word here is highest pH, and highest pH means that it's going to have the lowest hydrogen ion concentration. So that's how I would do it. I literally on the MCAT, you can highlight things or just highlight it in your brain, um, and um, and the word highest means the lowest hydrogen ion concentration. So clearly H2SO4 has some hydrogen ion. This NaHSO4 is going to have some hydrogen ion. This has no hydrogen ions at all. So this is going to have the lowest concentration of hydrogen ion because it has none of the solutions. So the answer is C. Of course, they're catching people just on that little trick of high pH means low hydrogen ion concentration. Could you imagine a question like this would be a typical MCAT type question, very typical, and yet they'll still catch a lot of students off. So question number 2, which of the following reactions is classified as a Bronsted-Lowry acid-base reaction? So go ahead, you have 15 seconds. Yes, so I think that concept is pretty clear. We've got the acid over here, which is acetic acid, happens to be an organic acid. It's a weak acid, but it's an acid nonetheless. It can donate a proton, and we have a base, NH3, which has a lone pair of electrons, and it accepts the proton, becoming NH4 plus. So we have a conjugate acid-base pair with acetic acid, and its conjugate base, meaning this is the base part that can accept the proton. And that's called the acetate anion. Anions are negative ions. So AN are negative anions. Anions, at least that's the little trick they give in, I don't know, grade 8 or grade 9 or whatever. So the answer is A, and then B, you could see what a Lewis acid and base does, which is you have NH3 as well, but NH3 this time is not accepting a proton. Rather, it's donating electrons, and it's donating electrons to BF3. Then you have HCl, which is just dissociating. Then you have water and sulfate. So yes, the correct answer here is A. So let's continue with some fun acid-base problems. So question 3, what is, oh, I know you're kicking yourself. Really, do we have to do that? Okay, so you've got 10 seconds to do question 3. Yeah, it's pretty basic. So negative log hydrogen ion concentration, and the hydrogen ion concentration here is 10 to the minus 3. So we have negative log of 10 to the minus 3 because we know we have a strong acid. It's HCl, so it completely dissociates. And so the pH is going to bring this minus 3 to the front. So we have 3 log 10 base 10, which is 1, so that's 3. Sorry I had to do it old school there, but just in case. And pH is POH. pH plus POH is equal to 14, so if you were asked the pOH for this would have been 11. So question 4, which of the following species can react either as a Bronsted acid or as a Bronsted base? So, I don't know, 10 seconds. Yeah, so that's good. This, this is clearly an acid. It can only donate a proton. It can't accept anything. B can only act as a base. It could accept protons, but it cannot donate a proton. C, again, the phosphate group can accept protons, but it cannot donate protons. And then here we have a substance that could potentially donate 1 or 2 protons, but at the same time, it could also accept 1 proton and become the neutral compound H3PO4. So answer choice D would be the correct answer there. And here, urine has a pH of approximately 6. What is the hydroxide ion concentration of urine? Here, there are your 4 answers. Okay, you have 30 seconds. Okay, so for question 5, I'm going to show you how I would do it on the MCAT, and then I'm going to show you the long way. But the way I would do this on the MCAT is I would say this is all about pattern recognition, right? So I see the pH is approximately 6, so I know that that's the hydrogen ion concentration to the 10 to the minus 6. I know that that is 10 to the minus 6. Why? Because I did a bunch of MCAT problems, and I know that that's how the game works. And I know that this equation is true, which is 10, to the minus 14. So I know that the OH concentration, OH minus, is equal to 10 to the minus 8. So that's how I would do it. And you have scratch paper, of course, for the new MCAT CBT, so you'll be able to do that. And the correct answer is C. The other way you could have done that is the pH plus pOH thing. So you know that pH plus pOH is equal to 14. So if pH is 6, that means the pOH is going to be 8. And we know that pOH is negative log hydroxide ion concentration. So, so that is equal to the negative log hydroxide ion concentration. So you take minus 1 you're going to want to isolate for hydroxide ion. So you multiply both sides by -1, so you have -8 is equal to log hydroxide ion concentration. And then using the rules of logarithms, you erase both sides to the power of 10. So you have 10 to the -8 is equal to 10 to the log hydroxide concentration, and 10 to the power of log 10 brings the hydroxide ion concentration down here. If you need to review the rules of logarithm, take a look at chapter 6 in the gold standard for general chemistry, and you'll find that all the rules of logarithms are there, and you have to be comfortable with them. So it'll just take you a little while, and you should be able to be very comfortable with those rules of logarithms. Last question for general chemistry. Question 1, suppose that 30 mils of 0.1 molar perchloric acid is added to 10 milliliters of 0.03 molar NaOH. What is the pH of the resulting solution? So you have 20 seconds to give a response. Yeah, this is a problem where you have perchloric acid, which is on our list of strong acids, and we have NaOH, which is on everybody's list of strong bases, sodium hydroxide. So that means what we're really talking about is H plus here, and we're talking about OH minus here. Well, without doing any calculations, we have 30 mils of that, 0.01 molar. We have 10 mils of that, 0.03 molar. So if you multiply the two, you see you're going to get the same number. So you know you've got the same number of moles of hydrogen as you have of OH minus. If you have the same number of moles of both, then we're talking about a neutral solution. So not only do we know the pH range, we actually know what the pH of the solution is. It's pH 7. So the answer has to be C. Of course, you can actually calculate it, but then you won't finish the physical sciences section of the MCAT. And some people don't finish it because they haven't done enough problems and they haven't been able to get into that pattern recognition thing. So, but you're not going to be one of those students. So any questions about general chemistry before we move on to biology? Okay, biology, chapter 6. Biology, chapter 6. So here there's obviously, with regards to all biology chapters, there's a ton of information. How much of it will you be tested on? A very, very small percentage. Because, you know, as I've said before, physics and general chemistry, you have to have your equations memorized, and you have to be comfortable in how to apply them. And that's critical. Organic chemistry, you have to understand mechanisms. That is critical. But biology, most of the problems are going to be based on information in the passage. Most of the problems are going to be based on tables, diagrams, research or experiments from the passage. That means it really depends on your ability to recognize patterns and doing lots of problems so that you're comfortable evaluating passages, tables, and diagrams. However, we have the time, so we might as well learn some stuff that they iterate as being important for you to know, but on a practical basis, there are very, very few questions that will directly test your knowledge on these areas. Very few questions in a biology section. But nonetheless, so let's talk about the nervous and endocrine system. So first we'll talk about the nervous system. So in terms of the nervous system, we can divide it in two different ways. One way to divide the nervous system is to divide it anatomically. And if you were to divide the nervous system anatomically, you would divide it into a central nervous system and a peripheral nervous system. Now, your central nervous system simply means your brain and your spinal cord. So that's the brain and the spinal cord. There we go. And your peripheral nervous system includes all the nerves. So those are all the parts of the body, the nervous system that's leaving or going to the brain and spinal cord. Now, there's another way to divide the nervous system, and that is in a functional sense. What does what? And if you were to divide the nervous system in a functional sense, you can divide it into the somatic nervous system, and that means all the parts of your nervous system that has to do with voluntary movement. And then there's the autonomic nervous system. So this is the, I'm sorry, I was going to write automatic, but that was a Freudian slip, because your autonomic nervous system is essentially the automatic nervous system. And that's the nervous system for which you do not have voluntary control. And when I say that, I'm speaking in general terms. Yes, I'm sure you've heard of some people who could do some, yoga or whatever, and can lower their heart rate to a certain level consciously, and so on and so forth. But on a daily basis, we don't wake up and say, okay, I'll take a heart rate of 62 beats per minute. We don't do that, and so there are tons of functions in our bodies that continually occur in an automated fashion, and that is regulated and overseen by our autonomic nervous system. So our autonomic nervous system, in turn, can be divided into two different systems. And these are systems that I'm sure you've heard of many times before, which of course is the sympathetic nervous system and the parasympathetic nervous system. So the sympathetic nervous system has to do with our fight, flight, and fright responses. So, and the parasympathetic nervous system are the vegetative responses. So the sympathetic nervous system, for example, something urgent occurs, or you're in a car accident, or somebody comes from behind a wall or something and says boo to you or something like that, and you have this sudden response. And so you can imagine how your sympathetic nervous system would kick into gear. Your heart rate would go up, for example. Your blood pressure would rise. Your pupillary size would increase, because it's urgent. There's something urgent that's occurring, so your pupil size increases because your body needs to get the maximum amount of information to either fight or run or whatever, but your body needs information, so pupil size increases, heart rate increases as blood is rushing through your system and getting to your muscles so that you can do whatever activity is required. And so blood flow is going to the skeletal muscle system and away from the gut. because it's not time to digest food and and so on. It's time to get something done. And whereas your vegetative response is when, oh, you're just hanging around, you're reading a book, you're lying down, and all of a sudden your stomach starts gurgling, or, which is really air's passing through your small intestine and the stomach as you're digesting food, and things are being transported from one part of your body to another as you have the time and energy to do so. Blood is going away from the skeletal muscle system, which is no longer required at that time, and being used rather for other processes. So that's the parasympathetic nervous system. And in general, now there are things that are, of course, connected to the central nervous system. Um, One part that is connected to the central nervous system, which are very important, comes from your eyes. Your eyes have neural tissue at the back. It has a retina, and the retina contains rods and cones. I'm sure you remember from high school, and you may remember also from high school that cones are for color, so C for color, and that means the rods are more for black and white vision, and um, and the the information is carried along an optic nerve, optic referring to eyes, opticians, blah, 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 ophthalmologist, and the optic nerve leads to the brain. So now, in the brain, there are different parts to the brain, of course. There's not many parts that are very important for the MCAT. Of course, there's a whole big list of it in the book, but in terms of the MCAT, things that might come up are things like the brainstem itself, and the brainstem is composed of the pons and medulla. So that's the pons and the medulla. And the brainstem is important for functions, very basic functions, like heart rate, blood pressure, respiration, things like that. So this is part of the anatomical part of the brain. Um, at the base of the brain, there's something that was once called the little brain. And the little brain is the cerebellum. And the cerebellum is important in balance and coordination. Now, what are you thinking with right now? Hopefully you're thinking with something right now, and you are thinking with the outer layer of your brain, which is called the cerebrum. So people who do a lot of thinking, like MCAT students, are generally called cerebral, and as opposed to art students. Just kidding, just kidding. Anyway, so the cerebrum, and so here there is um, oh, gray matter. It's because those are mostly cell bodies. Normally parts of the central nervous system or peripheral nervous system that are white, it's because it's more the axons. We talked about the neurons last week, and neurons have axons, and axons have myelin sheaths, and myelin sheaths are fatty, and fat can be yellow or white, and that's why peripheral nerves tend to be white, or yellowish white, or mostly white. And it's because they're filled with axons that have myelin sheaths around them. So gray matter, those are the cell bodies themselves, and that's what encompasses the human brain. And this is important for higher order thinking, memory, consciousness, things of that nature. So that's the cerebrum. So let's talk about the endocrine system. Now, the endocrine system, you've heard of endocrine and you've heard of exocrine. Exocrine is something we'll be looking at, in a few chapters, and exocrine, exocrine are things that exit the body, exocrine, and endocrine is within the body. So these are glands or organs that will secrete their products, which are normally hormones, and will secrete those products into body fluids that remain within the body system. Most often, those fluids are blood. We're talking about blood. Most often, it's hormones that are secreted into the blood. Now, the most important of these, it used to be thought that the pituitary gland was the master organ of the human body that controlled everything else in terms of the endocrine system. But there's actually a part of the brain above the pituitary gland, but below the thalamus, so it's called the hypothalamus. So, and this part of the brain actually releases things that are called releasing factors. And these releasing factors are types of hormones that will go to the pituitary gland and have, particularly the anterior pituitary gland, and have the pituitary gland release hormones. So there's all types of releasing factors related to hormones released by the anterior pituitary gland. For example, ACTH, RF is the adrenocorticotrophic hormone releasing factor. Now we'll see what ACTH does in a minute, but this is the releasing factor that goes to the anterior pituitary gland to get ACTH to be released. Then there's FSH, RF,